All right, your final exam is 25 questions, all multiple choice. And it goes over everything that we've done from when we got back from Christmas break up to now. So our first section within our review is just condensing each of these expressions to a single logarithm. When we condense these, we want to bring the number in front of that log to be the power on the big number. And then we want to undo any addition or subtraction or represent it with multiplication or division. So for number 1, we have 3 times log 9 of 2 minus 2 times log 9 of 5. Your base on both of these is the 9, which is what we're looking for. So we're going to bring the 3 to be the power on the 2 and the 2 to be the power on the 5. So that's going to give us log 9 of 2 to the third power minus log 9 of 5 squared. Next, you want to undo your subtraction and represent it with division. So you're going to keep that log 9. Just now divide the 2 to the third power by the 5 squared. You can leave it in exponential form like this, so you do not need to do 8 over 25. You can, like I said, leave it 2 to the third power over 5 squared. For number 2, we have log 6 of x plus log 6 of y plus 6 times log 6 of z. We all have the base of 6 here. The only term, or the only part that has a number in front of that log is the last one, so we'll put that to be the power on the z, and that'll give us log 6 of x plus log 6 of y plus log 6 of z to the 6th power. You have addition here. Addition means multiply, which means you're going to multiply your x, the y, and the z to the 6th power. So you're going to keep the log 6, then you're just going to have x times y times z to the 6th power. For number 3, we have 3 times log 2 of 3 minus 12 times log 2 of 7. Your 3 is going to become the power on the 3. The 12 becomes the power on the 7. So that gives you log 2 of 3 cubed minus log 2 of 7 to the 12th power. Once again, you have subtraction. We want to represent that with division. So that gives us log 2 of 3 cubed over 7 to the 12th power. The next part of our review, we are expanding each of these log. So with number 4, we have log 7 of x to the 4th power over y squared. We want to rewrite that division using subtraction. So this is going to give us log 7 of x to the 4th power minus log 7 of y squared. The power on each of these goes to the front of that log. So that's just going to give us 4 times log 7 of x minus 2 times log 7 of y. For number 5, we have log 5 of a cubed over b cubed. So again, we're going to undo that division using subtraction. So this is going to give us log 5 of a cubed minus log 5 of b cubed. Lastly, bring those powers to the front. So that's 3 times log 5 of a minus 3 times log 5 of b. For number 5, we have log 3 of z times the cube root of x times y. Now, if it's going to help you to rewrite this using multiplication, do so. This is the same exact thing as saying the log 3 of z times the cube root of xy. So in order to get rid of that multiplication, we represent it with addition. So this is going to give us log 3 of z plus log 3 of the cube root of xy. You do not leave the radical here, so you want to represent it with a power. So that's going to give us log 3 of z plus log 3 of xy to the power of 1/3. Once again, that power has to go to the front. So this moves to the front. So we're going to have log 3 of z plus 1/3 log 3 of xy. Now, you see that you have that xy in parentheses. You can expand this even further because there is addition there. However, that 1/3 is in front of that log 3. So when you separate that using addition, it's going to give that 1/3 in front of both of them. So that means that you're going to have log 3 of z plus 1/3 log 3 of x plus 1/3 log 3 of y. So because both the x and the y is underneath that radical of that third root, they both have to have that 1/3 in front of their log. For our next section, we are going to rewrite each equation in exponential form. So with these, we're just going from log to exponential. For number 7, we have log 16 of 256 is equal to 2. Remember, with these, we are dropping the log. The 16 comes up. 2 becomes your power, and your answer is your big number. So that's 16 to the second power is equal to 256. Remember, with these also, they should be true statements. If they are not, then there is something wrong with them. For number 8, you have log y of 76 is equal to x. So we're going to drop the log. Y comes up. Your 76 becomes your answer. X becomes your power. So y to the power of x is equal to 76. For number 9, we have log 2 of 1/8 is equal to -3. So again, we're going to drop the log. 2 becomes our base, or is our base. 3 is our power. The 1/8 becomes our answer. So 2 to the -3rd power is equal to 1/8. For 10, we have log y of 41 is equal to x. So just like number 8, dropping the log, y becomes our big number as our base. X becomes our power, 41 becomes our answer. So y to the power of x is equal to 41. Number 11 is a little different because it does not have a base on it. It's just log of x is equal to y. When there is no base on your log, it's understood that it's 10. So this is like saying log 10 of x is equal to y. That log disappears. 10 becomes the big number. Y becomes your power on the 10, and your x is your answer. So that's 10 to the power of y is equal to x. Your next section, we are rewriting each equation in logarithmic form. So we're going from exponential to log form. With these, you're going to need the word log. Your base on your left side or your right side, depending on what it is, the number that's raised to the power, becomes your little subscript number on the log. Your power becomes the answer. Your answer becomes the big number or the number after the log. So for 12, we're going to have 14 to the power of -2 is equal to 1 over 196. So this is going to give us log 14 of 1 over 196 is equal to -2. So that 14 drops. Your -2 becomes your power. Your fraction becomes the number after your log. For 13, you have 18 to the second power is equal to 324. So again, we're going to add in the log. 18 is your base, so that's your subscript number. 324 comes next, and it's equal to your power, which is 2. For 14, you have 14 squared is equal to 196. So again, we're going to have log 14 of 196 is equal to x. For 15, we have x to the power of y is equal to 101. So we're going to write in log x of 101 is equal to y. And then 16 is just like 15. You have x to the power of y again is equal to now 191. So log x of 191 is equal to y. For our next section, we're just solving each of these equations. So we're solving for x. Remember with these, if your base is the same on both sides, you're going to cancel out the base and just work with the powers. So for number 17, you have 5 to the power of 3 minus 2x is equal to 5 to the power of negative x. Because your base is the same on both sides, you're going to cancel out those 5s, and you're just going to work with the 3 minus 2x is equal to negative x. I'm going to move the 2x over by adding it to both sides. And this just gives us that x is equal to 3. For 18, we have 3 to the power of 2a is equal to 3 to the power of negative a. Your 3's are the same, so they're going to cancel. You're just going to work with the 2a is equal to negative a. We're going to move that negative a over by adding it to both sides. This gives us 3a is equal to 0. Divide each side by the 3, and you have that a is 0. For 19, we have 4 to the power of 2p is equal to 4 to the power of negative 2p minus 1. Once again, your bases are the same, so they cancel. You're going to work with 2p is equal to negative 2p minus 1. Move the 2p that's negative over by adding it to both sides. This leaves you with 4p is equal to negative 1. Divide each side by the 4 to get p by itself, and we get that p is equal to negative 1/4. For 20, you have 8 to the power of x minus 1 minus 2 to the power of x plus 2. For this one, your bases on both sides are not the same. You need to turn that 8 into the same base as that 2. So that 8 is the same thing as 2 cubed. This becomes 2 to the power of 3 times x minus 1 is equal to 2 to the power of x plus 2. Now that your base is the same on both sides, you can cancel them out and just work with the 3 times x minus 1 is equal to x plus 2. We're going to distribute the 3 into the x minus 1 first. So that's 3x minus 3 is equal to x plus 2. Move your x over, subtract it from both sides. That gives you 2x minus 3 is equal to 2. Move your 3 over, add it to both sides. That's 2x is equal to 5. Then divide each side by the 2, and you get that x is equal to 5/2. For 21, you have 5 to the power of 3x plus 1 is equal to 25 to the power of x plus 1. The 25 can turn into 5 squared, so we'll rewrite this as 5 to the power of 3x plus 1 is equal to 5 to the second power times the power of x plus 1. We're going to get rid of your bases since they are the same. At the same time, I'm going to distribute that 2. So we're going to work with 3x plus 1 is equal to 2x plus 2. Move the 2x over, subtract it from both sides. That gives you x plus 1 is equal to 2. Then move your 1 over, subtracting it from both sides. That gives you that x is equal to 1. For 22, we have 2 to the power of m plus 1 is equal to 16 to the power of m plus 7. The 16 is 2 to the 4th power, so this is going to turn into 2 to the power of m plus 1 is equal to 2 to the 4th power times m plus 7. Once again, bases are the same, they cancel. Distribute the 4 and work with your powers. So that's m plus 1 is equal to 4m plus 28. I'm going to move the m over by subtracting it from both sides. This gives us 1 is equal to 3m plus 28. Subtract 28 from both sides. This gives you 3m is equal to negative 27. From here, you're going to divide each side by the 3, and you have that m is negative 9. For 23, we have 36 to the power of 2x is equal to 216 to the power of x minus 1. 36 is 6 squared. The 216 is 6 cubed. Now that we have the same bases, we're going to cancel them and work with the 4x is equal to 3x minus 3. Subtract your 3x over, and you're left with x is equal to negative 3. For 24, we have 1/3 to the power of x plus 2 is equal to 3 to the power of x minus 1. That 1/3 is 3 to the negative first power. So we're just going to rewrite this to be 3 to the negative first times x plus 2 is equal to 3 to the power of x minus 1. Cancel out your 3's. Distribute your negative 1. Work with the negative x plus 2, or sorry, minus 2. Negative x minus 2 is equal to x minus 1. I'm going to move that negative x over, so I'm going to add it to both sides. This gives us negative 2 is equal to 2x minus 1. Then add the 1 to both sides. So 2x is equal to negative 1. Lastly, divide each side by the 2, and you have that x is equal to negative 1/2. For our next section, we are just simplifying these expressions. We are working with the imaginary number I with these. So remember, you're going to combine like terms here just like you would if you had variables. For 25, you have negative I plus 6i. This is the same thing as negative 1 times I plus 6 times I. So your like terms there have the I attached to them. 6 minus 1 is 5. You keep the I. So it's just 5i. For 26, you have negative 3i plus 3 plus 5i. You have addition between your two sets of parentheses, so you can get rid of them and just rewrite it using your addition. Your like terms here are the negative 3i and the 5i. So the 3 we're going to keep. Negative 3 plus 5 gives us positive 2. We keep the I on that, and that's just 3 plus 2i. For 27, again, we're just simplifying these. So we have negative 2i plus 5i. That gives us 3i. For 28, we have 3i plus 4i. So that's just 7i. For 29, we have negative 6 minus 2i plus 6 minus 5i. Addition between the two parentheses, we don't need the parentheses, so we're going to just eliminate them and combine like terms. For your real numbers, you have negative 6 and positive 6. They are opposites, so they cancel each other out. So the only thing that you have to simplify is a negative 2i minus 5i, which gives us negative 7i. For number 30, we have negative 5 plus 3i minus 4 minus 5i. We are going to work with the subtraction between the two sets of parentheses, so we're going to distribute the negative into that second set. We're going to rewrite this as negative 5 plus 3i minus 4 plus 5i. Remember, when you're distributing that negative, you're just changing the sign on everything. Add your real number parts first. The negative 5 plus negative 4 gives us negative 9. Then your imaginary, which is the 3i and the 5i, which gives us a positive 8i. So that's just negative 9 plus 8i. For 31, you have 3 minus 4i minus negative 5 plus 7i. You are going to distribute that negative into the second set of parentheses first. So that gives you 3 minus 4i plus 5 minus 7i. Combine your like terms, starting with your real numbers. 3 plus 5 gives you 8. The negative 4i minus 7i is negative 11i. So that is just 8 minus 11i. For number 32, you have 6 minus 8i minus 4i plus 7. That negative that's in front of that 4i goes with the 4i, so it's 6 minus 8i minus 4i plus 7. Combine your like terms, so the 6 plus 7 gives you 13. The negative 8i minus 4i is negative 12i. So that's just 13 minus 12i. For 33, you have negative 7 plus 7i minus negative 7 minus 3i plus negative 7 minus 8i. We're going to distribute the negative in front of the second set of parentheses, and that's going to leave us with negative 7 plus 7i plus 7 plus 3i minus 7 minus 8i. So once again, we combine like terms. That negative 7 matches with the positive 7, which are opposites, so they cancel. You do have the negative 7 left, so you drop that down. Next, you have 7i plus 3i, which is 10i, minus 8i is positive 2i. So that's just negative 7 plus 2i. For 34, you have negative 8 plus 6i plus 6 minus 6i plus 7 plus 6i. Addition is in between all of these parentheses, so just rewrite these without the parentheses and then combine like terms. Your negative 8 matches with the 6, that gives you negative 2. Plus the 7 is 5. Then you have the 6i minus 6i, which are opposites, so they cancel. And then the next 6i is just left over. So it's just 5 plus 6i. For 35, we are still simplifying, but now we have multiplication. So we have 3i times negative 2 plus 6i. We are going to distribute this negative 3i in and multiply it by both the negative 2 and the 6i. The 3i times negative 2 is negative 6i, and 3i times 6i is 18i squared. I squared is equal to negative 1. So we're going to change out this I squared for negative 1, and that's just going to give us negative 6i plus 18 times negative 1. The 18 times negative 1 is negative 18, so that's negative 6i minus 18. We rewrite this in a plus bi form, so that's negative 18 minus 6i. For 36, we have 5 minus 3i times negative 8 plus 5i. We're just going to FOIL this one out. So we're going to distribute the 5 in to the second set of parentheses, then distribute the negative 3i into the second set of parentheses. So this is going to give us negative 40 plus 25i plus 24i minus 15i squared. Once again, we change that I squared to be negative 1. We also are going to combine like terms with the 25i and the 24i. So this is going to leave us with negative 40 plus 49i minus 15 times negative 1. The negative 15 times negative 1 is positive 15, so we're going to combine that with the 40. So the negative 40 plus 15 gives us negative 25. So this is just negative 25 plus 49i. For number 37, we have negative 7i minus 4i minus 6 minus 6i. So the negative 7 times negative 6 is positive 42. Negative 7 times negative 6i is negative 42i. Negative 4i times negative 6i is a positive 24i. And negative 4i times negative 6i is a positive 24i squared. Once again, we're going to change out that I squared and combine like terms. So to combine like terms, we have that negative 42 plus 24, which gives us negative 18. So that's 42 minus 18i plus 24 times negative 1. The 24 times negative 1 is negative 24. So that's 42 minus 24 minus 18i. So this is just giving you 18 minus 18i. For 38, you have negative 5 plus 4i times negative 2 plus 2i. So we're going to FOIL this. This is going to give us 10 minus 10i minus 8i plus 8i squared. Combine your like terms, simplify your I squared. That gives you 10 minus 18i plus 8 times negative 1. This simplifies to be 10 minus 8 minus 18i. So that's 2 minus 18i. For 39, you have 5 times negative I times negative 4 plus 6i. You're going to multiply the 5 times negative I first. That's negative 5i times negative 4 plus 6i. From here, we'll distribute the negative 5i in to the set of parentheses, and we are left with 20i minus 30i squared. Again, the I squared is negative 1, so that's 20i minus 30 times negative 1, which is 20i plus 30. You rewrite this with the 30 in front, and that's just 30 plus 20i. For 40, you have negative 2 minus 3i times 7 plus 7i. The negative 2 times the 7 is negative 14. Negative 2 times 7i is negative 14i. Negative 3i times 7 is negative 21i. And negative 3i times 7i is negative 21i squared. Combine your like terms, simplify that I squared. The negative 14 minus 21 gives you negative 35i. So that's negative 14 minus 35i minus 21 times negative 1. This turns into positive 21, so negative 14 plus 21 is 7. So 7 minus 35i would be your answer. For 41, you are solving each of these equations by taking the square root on both sides, or sorry, squaring both sides. When you do this, you do have to check your solutions. Sometimes you'll have extraneous solutions. When you have these extraneous solutions, it means you're plugging your answer in and it does not work. It doesn't give you a true statement. So that's called an extraneous solution. So check for those when you're doing these. For 41, you have 2 is equal to the square root of 3x plus 34. We're going to get rid of the square root by squaring both sides because our index is 2. From here, we're going to work with 4 is equal to 3x plus 34. We are going to move the 34 over first by subtracting it from both sides. This leaves us with 3x is equal to negative 30. Divide each side by 3, and x is negative 10. If you plug the negative 10 in, you have 2 is equal to the square root of 3 times negative 10, which is negative 30, plus 34. That's the square root of 4, which is 2. 2 is equal to 2, so that is definitely a solution. For 42, you have 1 plus the square root of k plus 1 is equal to 9. You first have to isolate your radical with this. So move the 1 over by subtracting it from both sides. This gives you the square root of k plus 1 is equal to 8. From here, you are going to square both sides to get rid of that radical. So you're going to work with k plus 1 is equal to 64. Move your 1 over, subtract it from both sides. You get that k is equal to 63. Plug this in, check it. 63 plus 1 is the square root of 64, which is 8. 8 plus 1 is 9. 9 is equal to 9. That 63 is definitely your answer. For 43, you have 6 times the square root of 9x is equal to 18. You want to isolate that square root first by dividing each side by the 6. This gives you the square root of 9x is equal to 3. You will square both sides to get rid of the radical. and you're going to work with 9x is equal to 9. Divide each side by the 9, and you get that x is 1. Plug that in, simplify it. 9 times 1 is 1. The square root of 9 is 3. 6 times 3 is 18. 18 is equal to 18. It's definitely an answer. For 44, you have the square root of negative 4 minus x is equal to the square root of 3x plus 24. For this one, since your radical is on both sides, you're going to square both sides here to start with. It's going to cancel out each radical. You're going to work with negative 4 minus x is equal to 3x plus 24. We're going to move the x over first by adding it to both sides. That gives you negative 4 is equal to 4x plus 24. Subtract your 24 over. You have 4x is equal to negative 28. Divide each side by the 4. And you have that x is negative 7. Plug the negative 7 in, simplify. Negative 4 minus negative 7 is negative 4 plus 7, which is 3. That's the square root of 3. 3 times negative 7 is negative 21, plus 24 is 3. That's the square root of 3 also. The square root of 3 is equal to the square root of 3. That negative 7 is your answer. For 45, you have the square root of 2n plus 24 is equal to the square root of negative 8 minus 2n. We're going to start this one by taking each side and squaring it, getting rid of those radicals. So you'll have 2n plus 24, bless you, is equal to negative 8 minus 2n. Move your 2n over by adding it to both sides. This leaves you with 4n plus 24 is equal to negative 8. Move your 24 over now, subtract it from both sides. That gives you 4n is equal to negative 32. Divide each side by the 4, and you get that n is 8. Check your answer. 2 times 8 is 16, plus 24 gives us the square root of 42 times 8 plus 24 is the square root of 40, yes. So the next one is the negative 8 minus 2 times 8, which is negative 24. Right? No, this is a negative 8, I'm sorry. This is negative 8. So let's erase this so that way it looks right. This is negative 8. So try that. 2 times negative 8 plus 24 is the square root of 8. The negative 8 minus 2 times negative 8 is also the square root of 8. So this one works. For 46, you have the square root of negative 48 plus 14x is equal to x. Square both sides to get rid of that radical. This is negative 48 plus 14x is equal to x squared. We're going to move the 48 over. We're also going to move the 14x over. This gives us x squared minus 14x plus 48 is equal to 0. In order to solve this one, you are going to factor. 48 has factors of negative 6 and negative 8 that add up to be negative 14. So this factors to be x minus 6 times x minus 8 is equal to 0. Set them both equal to 0 and solve them. If we move the 6 over, we add it to both sides, giving us that x is equal to 6. If we move the 8 over, we add it to both sides, so we get that x is equal to 8. Plug these both in and simplify. The square root of negative 48 plus 14 times 6 gives us the square root of 36, which is 6. That 6 works. Do the 8 now. Negative 48 plus 14 times 8 gives us the square root of 64, which is 8, and then 8 is equal to 8. So both of those are answers or solutions. For 47, we have the square root of 6n plus 13 minus n is equal to 3. For this one, we're going to move the n over first, adding it to both sides. So we have the square root of 6n plus 13 is equal to n plus 3. Take both sides and square them. This is going to leave you with 6n plus 13 is equal to n squared plus 6n plus 9. Move your 6n over, subtract it from both sides. Move 13 over, subtract it from both sides. You're going to solve n squared minus 4 is equal to 0. This factors to be n minus 2 times n plus 2. Because you just have the n squared, not an n, also, you can also move the 4 over and have n squared is equal to 4. Take the square root of both sides and get that n is plus or minus 2. Plug both of these in and simplify though. 6 times negative 2 plus 13 is the square root of 1. The square root of 1 minus negative 2 is 1 plus 2, which is 3. 3 is equal to 3. So the negative 2 works. If you plug in the 2, 6 times 2 is 12, plus 13 gives you the square root of 25, which is 5. 5 minus 2 is 3. 3 is equal to 3. These are both solutions. For 48, you have the square root of x minus 6 plus 8 is equal to x. Start this one by moving the 8 over and subtracting it from both sides. You have the square root of x minus 6 is equal to x minus 8. Take both sides, square them, get rid of that radical. So you're going to work with x minus 6 is equal to x squared minus 16x plus 64. Move your 6 over, add it to both sides. Move your x over, subtract it to both sides. This leaves you with x squared minus 17x plus 70 is equal to 0. Your factors of positive 70 that add up to be negative 17 are negative 7 and negative 10. So this factors to be x minus 7 times x minus 10 is equal to 0. Set them both equal to 0 and solve them. Move your 7 over, add it to both sides. You get x is equal to 7. Move your 10 over, add it to both sides. You get that x is equal to 10. Check both of these. The square root of 7 minus 6 is 1. The square root of 1 is 1. 1 plus 8 is 9. 9 is not equal to 7. So this one is an extraneous solution. Check the 10 also. Make sure that's not an extraneous solution as well. 10 minus 6 is the square root of 4, which is 2. 2 plus 8 is 10. 10 is equal to 10. That one is your solution. The next section that we're going to look at works with solving these equations by taking the square root of both sides. Remember with these, when you take the square root of both sides of an equation, you have to put the plus or minus in front of your answer. So if we look at number 49, we have r squared is equal to 78. Take the square root of both sides, since that term that's squared is by itself. That 78 is divisible by 2. It would be 2 and 39. The 39 is just divisible by 3 and 13. You don't have another 2 that pairs up with it. You don't have another 3 or another 13 that pairs up with them. So this just simplifies to be r is equal to plus or minus the square root of 78. For 50, you have n squared minus 4 is equal to 77. We're going to add the 4 over to get n squared by itself. We get n squared is equal to 81. We take the square root of both sides, and we have that n is equal to plus or minus 9. For 51, you have 3m squared plus 7 is equal to 301. You are first going to subtract this 7 over to get 3m squared is equal to 294. From here, you're going to divide each side by the 3. You have m squared is equal to 98. From here, you're going to take the square root of both sides. So remember the plus or minus in front of your answer. That 98 is 2 and 49. The 49 is 7 and 7. So your 7s pair up. This gives you m is equal to plus or minus 7 square root 2. For 52, you have 6x plus 2 squared minus 4 is equal to 28. Start this one by subtracting the 4 from each side. you have 6x plus 2 squared is equal to 24. From here, take the square root of both sides. 24 is 4 and 6, 4 is 2 and 2, 6 is 2 and 3. 2 of those 2's pair up, so this gives you 6x plus 2 is equal to plus or minus 2 square root 6. Move the 2 over, subtract it from both sides. It is not like terms to the 2 square root 6. So you have to rewrite this as 6x is equal to negative 2 plus or minus 2 square root 6. From here, divide each side by the 6 and simplify. So your negative 2 is going to become negative 1, 2 becomes 1, 6 becomes 3. That's just negative 1 plus or minus the square root of 6 all over 3. For 53, you have 2 square root 8 minus the square root of 8. That square root of 8 needs to be simplified. You have 2 and 4. 4 is 2 and 2. So your 2 2's pair up. This is 2 times 2 square root 2 minus 2 square root 2. The 2 times 2 square root 2 is 4 square root 2 minus 2 square root 2. They are like terms because they are both the square root of 2. So combine what's in front of them. 4 minus 2 is 2. Keep the square root of 2. It's just 2 square root 2. For 54, you have negative 4 square root 6 minus the square root of 6. That square root 6 is just 1 square root 6. So negative 4 minus 1 is negative 5 square root 6. For 55, you have the negative 3 square root 12 plus 3 square root 3 plus 3 square root 20. The square root of 12, you have 4 and 3. The 4 is 2 and 2. So this is like saying the negative 3 times 2 square root 3. The 3 square root 3 does not change because it is simplified fully. Then the square root of 20 is 4 and 5. 4 is 2 and 2. The 2's pair up. So that's like saying 3 times 2 square root 5. Negative 3 times 2 square root 3 is negative 6 square root 3 plus 3 square root 3 plus 3 times 2 square root 5 is 6 square root 5. Your only like terms here are the ones with the square root of 3, so you combine those and you are left with negative 3 square root 5 plus 6 square root 5. For 56, you have negative 2 square root 45 minus 3 square root 20 minus 2 square root 6. The 45 is 9 and 5. 9 is 3 and 3. So that's negative 2 times 3, which is negative 6 square root 5. The square root of 20 is 4 and 5, like we said on the question before this. The 2's would pair up. Negative 3 times 2 square root 5 is negative 6 square root 5. Then you have that negative 2 square root 6, which does not simplify any further. So you just combine your like terms here, and you're left with negative 12 square root 5 minus 2 square root 6. Next, you have the cube root of 3 times the cube root of negative 20. This gives you the cube root of negative 60. Your negative is going to come out front. The 60 is 6 times 10. 6 is 3 and 2. 10 is 2 and 5. None of those factors happen 3 times. So this is just the opposite of the cube root of 60. For 58, you have 4 square root 15 times negative 3 square root 6 plus 5. We're going to distribute this in. However, when I go to do this, I'm not going to multiply what's underneath my radicals. I'm going to keep it as 2 factors being multiplied by one another. So this is going to give me negative 12 times the square root of 15 times 6 plus 20 square root 15. The 15 is 5 and 3. 6 is 3 and 2. Your 2 3's are going to pair up, so this is like saying negative 12 times 3 square root 5 times 2, which is 10. If you simplify this, it gives you negative 36 square root 10 plus 20 square root 15. For 59, you have negative square root 2 times the square root of 10 minus 4 square root 6. So we're going to multiply these in. This is going to give you the negative square root 2 times 10 plus 4 square root 2 times 6. Factor out the 10, factor out the 6. 10 is 2 and 5, 6 is 2 and 3. Your two 2's group up for both of these, so it's like saying the opposite of 2 square root 5 plus 4 times 2 square root 3, which then simplifies to be negative 2 square root 5 plus 8 square root 3. For 60, you have negative 7 plus the square root of 3x times 4 plus the square root of 3x. We're going to FOIL this out. So we're going to have negative 7 times 4, which is negative 28. Negative 7 times the square root of 3x is negative 7 square root 3x. The 3x times 4 is 4 square root 3x. And the square root of 3x times the square root of 3x is the square root of 3x to the second power. Your squared cancels out your radical. So you combine like terms. Other than that, you're left with negative 28 minus 3 square root 3x plus 3x. You can leave it in this form, but that is your answer. So if you look at number 61, just to close out this section, you have the square root of 3 plus the square root of 5x times the square root of 3 minus 5 square root of 5x. If we FOIL this, this gives us the square root of 3 squared minus 5 square root 3 times 5x plus the square root of 3 times 5x minus 5 square root 5x squared. The power of 2 cancels out the radical, so this becomes 3 minus 5 square root 15x plus the square root of 15x minus 5 times 5x. So this simplifies one more time with combining like terms and simplifying the negative 5 times 5x to be 3 minus 4 square root 15x minus 25x. For the next set of questions, you are solving each of these equations using your quadratic formula. Remember, your quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That will not be given to you on your final exam, so you do have to know that without it being given to you. For 62, we have m squared minus 5m minus 14 is equal to 0. Your a is 1, b is negative 5, and c is negative 14. If we plug these values in, this is going to give us x is equal to the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 14. And this is all over 2 times a, which is 1. That negative, or the opposite of negative 5 becomes positive 5. The square root of negative 5 squared is 25. Then that negative 4 times negative 14 gives us positive 56. And this is all over 2. From here, we're going to add the 56 with the 25 underneath that radical, and we get x is equal to 5 plus or minus the square root of 81 all over 2. This then simplifies to be 5 plus or minus 9 over 2. So because that radical simplifies fully, we're going to separate this into two parts. One that is x is equal to 5 minus 9 over 2, and one that is 5 plus 9 over 2. The 5 minus 9 is negative 4 over 2, which then simplifies to negative 2. The 5 plus 9 gives us 14 over 2, which simplifies to be 7. So you have two solutions here, one that's -2, one that is 7. For 63, we have 2x squared minus 3x minus 5 is equal to 0. So your A is 2, B is -3, and C is -5. Plugging these values in, we're going to have the opposite of -3 plus or minus the square root of -3 squared minus 4 times 2 times -5 all over 2 times 2. The opposite of -3 is +3. The -3 squared is 9. -4 times 2 is -8 times -5 is +40. And that's all over 4. From here, we add underneath that radical to get 3 plus or minus the square root of 49, all over 4. The square root of 49 is 7, so that's 3 plus or minus 7 over 4. Once again, we're going to separate this into two parts. So 3 minus 7 over 4, and 3 plus 7 over 4. The 3 minus 7 gives us -4 over 4, which is -1. And the 3 plus 7 gives us 10 over 4, which simplifies to be 5 over 2. For 64, we have 2m squared minus 7m minus 13 is equal to -10. Your A is 2, B is -7, C is not 13. You have to move the 10 over, so then that would become a -3. So if we plug these in, we have the opposite of -7 plus or minus the square root of -7 squared minus 4 times 2 times -3 all over 2 times 2. The opposite of -7 is +7. The -7 squared is 49. The -4 times 2 is -8 times -3 is a +40. And this is all over 4. This then simplifies to be 7 plus or minus the square root of 89 over 4. You cannot take the square root of 89, so you would leave it as 7 plus or minus the square root of 89 over 4. For 65 through 67, you're stating the domain in interval notation. With these, remember, you're taking the denominator, setting them not equal to 0, and then solving. So for 65, you have y is equal to 1 over x minus 2. Take the x minus 2, set it not equal to 0, and solve. Add your 2 over. You get that x cannot equal to 2. From here, you're going to put this into interval notation. So if x cannot equal 2, think about it on a number line. You're going from 2 all the way to -infinity and 2 to +infinity. So that's going from -infinity up to 2 with a union of 2 to infinity. And remember, those parentheses go on the 2 since we're not including the 2. It's not equal to the 2. For 66, we have f of x is equal to x cubed over x squared minus 4x minus 96. We're going to take that x squared minus 4x minus 96, set it not equal to 0, and then solve. You can either factor this or use your quadratic formula, whichever you choose. You can also use the completing the square method. Totally up to you. With this, your 96 has factors of 1 and 96, 2 and 48, 3 and 32, 4 goes in 24 times, 5 does not go in evenly, 6 goes in 16 times, 7 does not go in evenly, 8 goes in 12 times. If the 12 is negative and the 8 is positive, that gives you that -4. So this factors to be x plus 8 times x minus 12 is equal to 0, or is not equal to 0. Since this is factored, set both parts not equal to 0 and solve them both. Move your 8 over, subtracting it from both sides. So x cannot equal -8. Move your 12 over, add it to both sides. X cannot equal 12. Use a number line. If you have -8 and you have 12, you would have an open circle on the 8, an open circle on the 12, and your line would go from -infinity up to that -8, between the -8 and the 12, and from that 12 to positive infinity. So that means your interval notation would go from -infinity to -8, with a union from -8 to 12, with a union from 12 to infinity. For 67, you have y is equal to 3x squared minus 8x over 2x squared minus 5x minus 3. We're going to take the denominator, set it not equal to 0, and solve. Since you have an a that's something other than 1, you're going to multiply that a and that c. That gives you -6. You want the factors of -6 that are going to replace the -5. If you have that -6, your factors are 1 and -6 that equal -5. So this is going to turn into 2x squared plus x minus 6x minus 3 is not equal to 0. Because you have 4 terms now, you're going to factor this by grouping. Factor out an x from the first set, factor out a -3 from the second. This gives you x times 2x plus 1 minus 3 times 2x plus 1 is not equal to 0. The two sets of parentheses that are left over are identical to one another, so write that as 2x plus 1 times x minus 3 is not equal to 0. From here, you're going to set both of these not equal to 0 and solve them. For the 2x plus 1 is not equal to 0, subtract your 1 over. That gives you 2x is not equal to -1. Then divide each side by the 2, so x cannot equal -1/2. For x minus 3 is not equal to 0, add your 3 over, so x cannot equal 3. Once again, use a number line to help yourself. If you have -1/2 on there and +3, you would have open circles on both, and it would include everything in between and from -infinity to positive infinity. So this means that your interval notation for this is going to go from -infinity up to -1/2, with a union from -1/2 to 3, with a union from 3 to infinity. The next section that we're going to look at goes over factoring each of these expressions completely. If we look at number 68, you have a squared minus 12a plus 20. Your factors of 20 that add up to be -12 are -2 and -10. So this just factors to be a minus 2 times a minus 10. For 69, we have n squared minus 2n minus 24. Your factors of -24 that add up to be -2 are 6 and -8. So this factors to be n plus 6 times n minus 8. For number 70, you have a squared plus 3a minus 54. Your factors of -54 that add up to be 3 are 6, or -6, sorry, and +9. So this is a minus 6 times a plus 9. For 71, you have 7n squared minus 45n plus 18. Because your a is something other than 1, we're going to multiply 7 times 18. That gives us a positive 126. We want the factors of 126 that add up to be -45. If we divide that by 3, or -3, it would be -42, which gives us the -45. So we're going to just rewrite this as 7n squared minus 3n minus 42n plus 18. Factor this by grouping. Divide out an n from the first, divide out a -3 from the second. This then gives you n times 7n minus 3, minus 3 times 7n minus 3. Your two parentheses are identical, so that's 7n minus 3 times n minus 3. For 72, we have 2x squared plus 13x minus 24. That 2 times negative 24 is negative 48. You have to find your factors of negative 48 that add up to be a positive 13. We have 1 and 48, 2 and 24, 3 and 16. If the 16 is positive and the 3 is negative, that gives us the 13 that we're looking for. So that's 2x squared minus 3x plus 16x minus 24. We're going to factor by grouping. So x factors out from the first, and 8 factors out from the second. So that gives us x times 2x minus 3 plus 8 times 2x minus 3. Once again, parentheses are the same, so that just simplifies to be 2x minus 3 times x plus 8. For 73, we have 9x squared minus 9x minus 10. So again, we're going to do 9 times negative 10. That gives us negative 90. Your factors of negative 90 that add up to be negative 9 are, well, we have 1 and 90, 2 and 45, 3 and 30, 4 does not go in evenly, 5 goes in 18 times, right, 4 does not go in, yeah. Then we have 6 that goes in 15 times. If the 15 is negative and the 6 is positive, that gives us the negative 9. So we're going to rewrite this as 9x squared plus 6x minus 15x minus 10. Factor by grouping. Factor out a 3x from the first, a negative 5 from the second. This gives you 3x times 3x plus 2 minus 5 times 3x plus 2. Rewrite this as 3x plus 2 times 3x minus 5. For 74, we have 5n cubed plus 20n squared plus 3n plus 12. We're going to factor this one by grouping because we are starting with 4 terms. We're factoring out a 5n squared from the first and a positive 3 from the second. This gives us 5n squared times n plus 4 plus 3 times n plus 4. Your two parentheses are the same. So we're going to rewrite this as n plus 4 times 5n squared plus 3. You cannot factor this any further, so this is your answer. For 75, we have 56b cubed minus 21b squared minus 48b plus 18. So again, we're going to factor this by grouping. Between the 56 and the 21, your greatest common factor is 7. We're going to do the b squared also. From the negative 48b and the 18, we're going to do a negative 6. So this gives us 7b squared times 8b minus 3 minus 6 times 8b minus 3. 8b minus 3 is the same, so we're going to keep that and then form another with the 7b squared minus 6. For 46, we have 42r cubed minus 18r squared minus 49r plus 21. Again, factor this by grouping. Factor out a 6r squared from the first and a negative 7 from the second. This gives us 6r squared times 7r minus 3 minus 7 times 7r minus 3. Sets of parentheses are the same. So we have 7r minus 3 times 6r squared minus 7. For 77, we have 9p squared minus 25. You can take the square root of both of these terms, and they are separated by negative, so this is a difference of squares. The square root of 3p squared is, 9p squared is 3p. The square root of 25 is 5, so that's just 3p minus 5 times 3p plus 5. For 78, we have 4x squared minus 20x plus 25. For this one, you can take the square root of that 2x or the 4x squared, that's 2x. The square root of 25 is 5. If we do a negative 2 times 2x times 5, that gives us that negative 20x. So this is a perfect square trinomial. So we're going to keep the sign in the middle, use the 2x and the 5. That's 2x minus 5 squared. For 79, you have a to the 4th power minus 9a squared plus 18. You have factors of 18 that add up to be negative 9. They are negative 3 and negative 6. So this, because it's a to the 4th, is going to factor to be a squared minus 3 times a squared minus 6. Check to see if you have the difference of squares with any of these, which you don't. So that is your answer. For number 80, you have u to the 4th power plus 12u squared plus 27. Your factors of 27 that add up to be 12 are 3 and 9. Again, you have that u to the 4th power, so this is going to factor be u squared plus 3 times u squared plus 9. Again, no difference of squares here, so this is your answer. For 81, you have 7x to the 4th power minus 59x squared minus 36. Multiply your a and your c. So 7 times negative 36 is negative 252. Find the factors of negative 252 that add up to be negative 59. If you divided this by 4 and negative 63, that would give you the negative 59 that you're looking for. So we can rewrite this as 7x to the 4th power plus 4x squared minus 63x squared minus 36. We're going to factor this by grouping. From the first, we're just factoring out an x squared. From the second, we're factoring out a negative 9. So this gives us x squared times 7x squared plus 4 minus 9 times 7x squared plus 4. We're going to rewrite this as 7x squared plus 4 times x squared minus 9. Check for any difference of squares. You can take the square root of that x squared. You can take the square root of the 9. There's subtraction between it. So this factors even more to be 7x squared plus 4 times x minus 3 times x plus 3. For 82, you have 3x to the 4th power plus 34x squared plus 63. You are going to start this one by multiplying your 3 and your 63. That gives you 189. Find the factors of 189 that add up to be positive 34. If we divide that 189 by 7, we get 27. And if we add those, we get 34. So we're going to rewrite this to be 3x to the 4th power minus 7x squared plus 27x squared plus 63. Factor this by grouping. Factor out an x squared from the first and a positive 9 from the second. This gives you x squared times 3x squared minus 7 plus 9 times 3x squared plus, this should be a positive 7x squared. So this is also a positive, there we go, plus 7. All right, so now our two parentheses are the same. So we have 3x squared plus 7 times x squared plus 9. Can't factor this any further, so that is your answer. For the next set of questions, you are solving each equation by completing the square. For 83, you have x squared plus 14x plus 48 is equal to 0. First thing you do here, move your 48 over, subtract it from both sides. This gives you x squared plus 14x is equal to negative 48. Take your b term, divide it by 2, and square it. This is going to give you 14 over 2 squared, which is 7 squared, which is 49. Add that 49 to both sides of your equal sign. You get x squared plus 14x plus 49 is equal to negative 48 plus 49. Factor the left, add the right. You get x plus 7 squared is equal to 1. Get rid of that x plus 7 squared by taking the square root of both sides. Remember your plus or minus. Because this is not leaving you with a radical, you're going to separate this into two equations and solve both. So you're going to have x plus 7 is equal to negative 1, and x plus 7 is equal to positive 1. Move the 7 over. You have x is equal to negative 7. I'm sorry, yeah. Why did I, oh yeah. We're doing the same thing. Move the other 7 over, subtracting it from both sides. And you get that x is equal to negative 6 as well. So negative 7, negative 6. So this is not negative 7. This is negative 8. There we go. Now for 84, you have n squared plus 12n minus 64 is equal to 0. For this one, we're going to move the 64 over, adding it to both sides. This gives you n squared plus 12n is equal to 64. Take your b, divide it by 2, and square it. That's 6 squared, which is 36. Add your 36 to both sides of your equal sign. So you have n squared plus 12n plus 36 is equal to 64 plus 36. If we factor the left, add the right, we have n plus 6 squared is equal to 100. Take the square root of both sides. That's n plus 6 is equal to plus or minus 10. Separate this. N plus 6 is equal to negative 10. N plus 6 is equal to positive 10. Move your 6 over on each of these by subtracting it. And you get that n is equal to negative 16 and n is equal to 4. For 85, you have b squared plus 6b minus 24 is equal to negative 8. You're still going to move that c term over by adding it to both sides. This gives you b squared plus 6b is equal to 16. Take your b, divide it by 2, and square it. That gives you 3 squared, which is 9. Add the 9 to both sides. So that's b squared plus 6b plus 9 is equal to 25. This then simplifies to b plus 3 squared is equal to 25. If you take the square root of both sides, you have b plus 3 is equal to plus or minus 5. So separate this into two equations. You have b plus 3 is equal to negative 5, and b plus 3 is equal to positive 5. Move your 3 over. You get that b is negative 8, and b is 2. For your next set of questions, you're taking square roots here. So if we look at number 86, you have 8n squared minus 4 is equal to negative 114. We're going to solve this one first, or start this one by adding the 4 to both sides, getting the 8n squared by itself. From here, you're going to divide each side by that 8. You can simplify this, and you're going to be left with negative 55, right? 110 divided by 2 is 55, yes, over 4. We're going to take the square root of both sides. You're going to have n on the one side. That 55 is just 5 and 11, so it cannot simplify. However, the square root of 4 is 2. That I comes out front because of the negative that's underneath. And you have plus or minus, let's do this, plus or minus I square root 55 all over 2. For 87, you have 2n squared minus 4 is equal to 102. We're going to add the 4 over. This gives us 2n squared is equal to 106. Divide each side by the 2. And you have n squared is equal to 53. Take the square root of both sides, and you get that n is equal to plus or minus the square root of 53. And for 88, you have 25a squared plus 4 is equal to 8. Start by subtracting your 4 over. That gives you 25a squared is equal to 4. Divide each side by the 25. You have a squared is equal to 4 over 25. Take the square root of both sides, and you have that a is equal to plus or minus 2/5. For 89, you're simplifying these expressions. Remember, your fractions mean division. So for 89, you have 4 over x plus 2 over 5 plus 4 over x plus 2. This is the same exact thing as saying 4 divided by x plus 2 over 5 plus 4 over x plus 2. You need a least common denominator in order to add those two fractions. Your least common denominator is going to be the 5 times x plus 2. So the first fraction we multiply x plus 2, second we multiply by 5. That's going to give us 4 divided by x squared plus 4x plus 4 over 5 times x plus 2 plus 20 over 5 times x plus 2. From here, add your numerators. That's going to leave you with 4 divided by x squared plus 4x plus 24 all over 5 times x plus 2. You can simplify the numerator of this fraction, that x squared plus 4x plus 24, by factoring it. You have factors of 24. You may check to see if you have factors of 24 that add to 4. Your factors of 24 are 1, 24, 2 and 12, 3 and 6, 3 and 8, 4 and 6. None of those add up to be 4, so it's going to stay the way you see it. So with division of fractions, you're going to keep the first, change to multiplication, then flip the second, and then multiply straight across. So this is going to give you 4 times 5, which is 20, times x plus 2, all over x squared plus 4x plus 24. For number 90, you have 2u over 4 minus 4 over u. So again, this is the same thing as saying 2u or 2u over 1 divided by u over 4 minus 4 over u. Least common denominator there is just 4u. So the first one gets multiplied by u, second gets multiplied by 4. That leaves you with 2u over 1 divided by u squared minus 16 over 4u. Factor the u squared minus 16. It is a difference of squares, so that's 2u over 1 divided by u minus 4 times u plus 4, all over 4u. From here, we can keep change flip, and so that's going to be 2u over 1 times 4u over u minus 4 times u plus 4. We multiply straight across here, and we get 8u squared over u minus 4 times u plus 4. For our next one, we have 1/2 plus 2 over x squared divided by x over 4. So again, I'm just going to rewrite this. Add my first set of parentheses. My least common denominator is or 2x squared. So this turns into 2x squared plus 4 over 2x squared divided by x over 4. I'm going to factor what I can on the numerator of that first fraction. That gives me 2 times x squared plus 2 over 2x squared. You can then simplify the 2's, so you just have x squared plus 2 over x squared. You're going to keep change flip with this at the same time, so it's going to multiply by 4 over x. This then simplifies to be 4 times x squared plus 2 over x cubed. For 92, you have 5 over 7p times 7p squared plus 21p over p squared minus 6p minus 27. You're going to factor everything that you can to start with. That first fraction is going to stay 5 over 7p. However, the second fraction's numerator, you can factor out a 7p. So that's going to be 7p times p plus 3. Your denominator, your factors of negative 27 that add up to be negative 6 are 3 and negative 9. So that's p plus 3 times p minus 9. Simplify before you multiply. You can cross simplify and then simplify within the same fraction as well. Your 7p's cancel. Your p plus 3 also cancels. So you just have 5 over 1 times 1 over p minus 9. So that's 5 over p minus 9. For 93, you have k squared plus 10k plus 24 over k plus 6 times 10 over k plus 4. For this one, we're going to factor the numerator of the first fraction. Your factors of 24 that add up to be 10 are 4 and 6. So that's k plus 4 times k plus 6 all over k plus 6 times 10 over k plus 4. In the same fraction, you have a k plus 6, so those cancel. Diagonally, you have a k plus 4, so those cancel. So it's literally just 1 times 10, which is 10. For 94, you have 3x over 3x squared plus 18x times x squared plus 16x plus 60 over 4x. The 3x squared plus 18x factors to be 3x times x plus 6. The numerator of the second fraction factors to be x plus 6 times x plus 10. If we simplify those the 3 and the x both simplify, you have the x plus 6 that also simplifies. So that's just x plus 10 over 4x. For 95, we have 6 over x minus 2 divided by x squared plus 13x plus 42 all over x plus 7. Your numerator of the second fraction factors with factors of 6 and 7. So this is 6 over x minus 2 times x plus 7 over x plus 7 times x plus 6. Your x plus 7's cancel. From here, you're just going to have 6 over x minus 2 times x plus 6. Leave it in factored form. This is your answer. For 96, we have 5 over 8n divided by 10n cubed minus 35n squared all over 16n squared minus 56n. We're going to keep change flip and factor at the same time. So it's going to give us 5 over 8n times the 16n squared minus 56n. You can factor out a 16, I think. No, the 56 is divisible by 8. So factor out an 8 and an n. So that gives you 2n minus 7. Your numerator becomes your denominator. You're going to factor out a 5n squared from that, and you're going to have 2n minus 7 left. Your 2n minus 7s can cancel. The n on the top of the first, or sorry, the 8n and the 8n would cancel. The 5s also cancel. So we just have 1 over n squared times nothing. So just 1 over n squared. For 97, you have 3n plus 2 over n minus 5 plus 2 times n plus 4. Your least common denominator here is the n minus 5 times n plus 4. The first fraction, we multiply by n plus 4. Second fraction's numerator, we multiply by n minus 5. So that's going to give us 3n squared plus 12n plus 2n plus 8 plus 2n minus 10 all over your least common denominator, which is n minus 5 times n plus 4. From here, just combine your like terms. So that's going to be 3n squared. You have 12n plus 2n, which is 14n, plus 2n is 16n. And then you have the 8 and the negative 10, which is negative 2. And this is all over n plus 4 times n minus 5. If you could factor that n squared plus 16n minus 2, you would. However, you don't have any factors of negative 6 that add up to be 16, so that is your answer. For 98, you have n minus 3 over 3m squared plus 18m plus 3 over 2. Your 3m squared plus 18m factors to be 3m times m plus 6. So your least common denominator is that multiplied by 2. So we're going to multiply the second fraction by the 3m squared plus 18m. Your first fraction, we're just going to multiply that by 2. So this is going to be 2m minus 10 plus 9m squared plus 18 times 3 gives us 54m. And then this is all over 2 times 3m times m plus 6. Combine your like terms up top if you have any. That 9m squared is going to go down first. Then you have 2m plus 54m, which is 56m, and then the negative 10. And this again is all over 2 times 3m times m plus 6. And again, if you could factor that numerator, which you can't, you would also do that. For 99, you have 6 over 2, which is 3, plus 5x over x plus 4. Least common denominator here is 2 times x plus 4. So we're going to multiply the 6 by x plus 4, the 5x by 2. This is going to give us 6x plus 24 plus 10x over 2 times x plus 4. This then simplifies to be 16x plus 24 all over 2 times x plus 4. This top can factor. You can factor out an 8. That gives you 2x plus 3 over x plus 4 times 2. From here, your 8 and your 2 also simplify as well. So this just simplifies fully to be 4 times 2x plus 3 over x plus 4. For 100, we have 4 over x plus 6 minus 4x over x minus 2. Least common denominator here is the x plus 6 times x minus 2. I want you to turn this into addition and make the 4x a negative 4x. This is going to help you remember to distribute that negative into whatever you're multiplying that numerator by. So the 4 gets multiplied by x minus 2. The negative 4x gets multiplied by x plus 6. So this is going to give you 4x minus 8 minus 4x squared minus 24 all over x plus 6 times x minus 2. From here, combine your like terms up top. You have negative 4x squared plus 4x minus 32 all over x plus 6 times x minus 2. Factor the top. You have a greatest common factor of negative 4, so that factors to be x squared minus x plus 8 all over x plus 6 times x minus 2. You cannot factor that numerator any further, so we're going to keep that as our answer. For 101, you have 3b over b minus 4 minus 4b over 2b plus 6. I'm going to simplify this because the top and the bottom of that second fraction are all, your terms are divisible by 2. So this is going to become a b, this becomes 3, this becomes negative 2b. So that's 3b over b minus 4 plus negative 2b over b plus 3. This will be a little bit easier to work with, so that way you're not completely simplifying at the end. Your least common denominator here is b minus 4 times b plus 3. So this top of the first fraction gets multiplied by b plus 3. Second gets multiplied by b minus 4. So we are going to have 3b squared plus 9b minus 2b squared plus 8 all over b minus 4 times b plus 3. Combine your like terms. You're left with b squared plus 9b plus 8 all over b minus 4 times b plus 3. If we factor this completely, the top has factors of 1 and 8 that add up to be 9. So that's b plus 1 times b plus 8 all over b minus 4 times b plus 3. For 102, we have r plus 2 over 2r minus r plus 4 over 2r minus 4. I'm going to rewrite this all. This is going to turn into addition, and I'm going to distribute that negative into my numerator. So this is going to give us r plus 2 over 2r plus negative r minus 4 all over 2 times r minus 2. If I can simplify from here, I would. However, I can't. So I'm just going to find my least common denominator. And it's going to be the 2r times 2r minus 4. Multiply the top of the first fraction by the 2r minus 4. Top of the second by 2r. So this gives us 2r squared minus 4r plus 4r minus 8. Then we have negative 2r squared minus 8r. From here, we combine like terms up top. The 2r squared minus 2r squared cancels. You have the 4r and the negative 4r that cancels, and you have that negative 8r and that minus 8. If we then simplify that numerator again, we're going to factor out a negative 8 to give us r plus 1 over 2 times 2r times r minus 2. Simplify your negative 8 and your 2. That becomes a negative 4 and a 1. The negative 4 and the 2r then also simplifies to become a 1r and a negative 2. So that's negative 2 times r plus 1 all over r times r minus 2. For 103, we have 1 over n squared minus n minus 6 over n squared is equal to 1 over 2n squared. Your least common denominator here is 2n squared, so we're going to multiply the entire thing by 2n squared. This means that this is going to end up as 2 minus 2n squared, 2 times n minus 6 is equal to 1. Distribute the negative 2. That's 2 minus 2n plus 12 is equal to 1. Combine your 12 and your 2. That's negative 2n plus 14 is equal to 1. Subtract your 14 from both sides. You get negative 2n is equal to negative 13. Divide each side by the negative 2. And you have that n is 13 over 2. For 104, you have x minus 1 over 3x is equal to x minus 6 over x plus 1/3. For this one, your least common denominator is the 3x. So we're going to multiply the entire thing by 3x. We're going to keep the x minus 1. We're going to multiply 3 by x minus 6 and multiply the x by 1. From here, distribute the 3. So this is going to give us x minus 1 is equal to 3x minus 18 plus x. Combine your like terms on the right side. You have x minus 1 is equal to 4x minus 18. I'm going to move the 1x over, subtracting it from both sides. That gives us negative 1 is equal to 3x minus 18. We add the 18 over. So we have 3x is equal to 17. Divide each side by the 3. And x is 17 over 3. For 105, you have 2 over 3k is equal to 1 over 3k minus 1 over 3k squared. For this one, your least common denominator is 3k squared. So we're going to multiply everything by that 3k squared. That means that this is going to turn into 2k is equal to k minus 1. Subtract your k over. That's k is equal to negative 1. The last section of your review goes over transformations. You are stating every transformation from these given functions. For 106, you have f of x is equal to x minus 2 squared plus 4. If you remember, inside the parentheses, if it's after the x, think opposite of what it is. So take the opposite of negative 2, that would be positive 2, which means we're going to the right 2 units. Then that plus 4 outside means that we're going up 4. For something like 107, where you have f of x is equal to the opposite of x plus 5 squared minus 1, the negative that's out front reflects vertically. So that's a reflection over the the x-axis. Then you have that plus 5 on the inside, so think opposite. That's going left 5 units. And then the minus 1 is on the outside, so that's down 1 unit. For 108, you have f of x is equal to 1/2 times the square root of negative x plus 1. The 1/2 is in front of that radical, so it's going to stay the 1/2. That means that it's a vertical compression, since it's less than 1, by 1/2. Then on the inside of your parentheses, or inside of your radical, you have a negative, so it's going to reflect horizontally, which means it goes over your y-axis. And lastly, that plus 1 after the radical means we're going up 1. For 109, you have f of x is equal to negative 3 times x minus 4 squared minus 2. This has a little bit more going on with it. You're going to start with that negative. It reflects over your x-axis. The 3 is on the outside in front of, so it's a number greater than 1. We have a vertical stretch by a factor of 3. We're going right 4 and down 2. For 110, you have 3, or f of x is equal to 3 times 2/3 x plus 9 squared. The 3 is in front on the outside, so that's going to be a vertical stretch by 3. The 2/3, it's on the inside in front of x, so take the reciprocal of it. it becomes 3 over 2. 3 over 2 is greater than 1, so that's a horizontal stretch by a factor of 3 over 2. Next, we have that plus 9, so think opposite. Negative 9 would be to the left 9 units. And the last one, f of x is equal to the opposite of the square root of 5x minus 2 plus 4. The negative in front reflects across your x-axis. The 5 is going to turn into 1/5 because you take the reciprocal of it. That 1/5 is less than 1, so that is a horizontal compression by a factor of 1/5. The minus 2, take the opposite. That's positive 2, so we're going to the right 2 units. And then the plus 4, we go up 4. So this concludes your review for your senior final. Once again, finals for seniors, 25 questions, all multiple choice.